Hey guys, a very good morning everyone. Welcome to the class and welcome to the special mock test for the BEL exam. Yes, so BEL is going to recruit you, and the recruitment exam is in December tentatively. They haven't announced the exact date, but December is no far, it's just 1 month left. Anytime the date can be announced. Okay, and it's a golden opportunity, especially for electronics engineering, because 125 vacancies only for electronics. It's a bumper vacancies for electronics. So, you should take, all such exams separately, because, those who are prepared for GATE or ESE, these are all, the second chances. And multiple second chances you are getting. It's not about a single second chance, multiple second chances you are getting. Okay, and BEL is one of them. Many other exams are also happening for you separately. All right. Yes. Okay, so very good morning everyone. Good morning Manoj, Puranchal, Kilari, Manasvi, Ashish, Kumar. Very good morning everyone, and quickly update all your friends that the session is now live. Okay, so let me brief you about this mock test and let's get started. Okay, and important updates in the beginning that yes guys, today Sunday, that is 5th November. Today, that is a Sunday, that is the 5th November. Okay, you get a chance, okay, to earn as much as up to 90% scholarship on the GATE and ESE preparation fees for the BYJU'S exam prep. Yes guys, just appear in the national scholarship test, prove yourself, and win your amount, earn your respect, I would say, and you can then take a next step towards success in GATE by enrolling to the full-fledged courses. Okay, the test started 9 a.m. and anytime you can give in the test up to the 9 p.m. as per your convenient time. Also guys, on the BYJU'S exam prep, all your favorite, the dashing Joshit sir, he is going to come live Wednesday. Okay, for all GATE 2025 aspirants, what should be the complete roadmap to secure the rank under 100 in the GATE 2025 examination? Joshit sir, Wednesday 8 November is going to give you complete and full-fledged guidance about the same. Right. Good morning Praveen, good morning Gaurav. Okay. Chalo. So guys, okay, so before I start up the test, let me tell you that yeah. So in this particular test, in this particular session, okay, you will have the complete syllabus. I mean, all subjects will be there. Okay, all subjects will be there, and total today you are going to face 50 questions. Okay, so we have kept the mock test of 50 questions, okay, from miscellaneous all subjects. Okay, so you're going to get network, control, EMT, analog, digital, EDC, everything. Okay, everything, right? Also out of this 50 questions, question number 1 to 25 will be taken by me. Question number 26 to 50 will be taken by all your favorite Sanjay Rathi sir. Okay, and 1 to 25 I will be taking. Okay, so one by one, okay, we'll be dealing with the questions. Yes, Varsha, it's government exam BEL. Okay, so chalo guys, so let's get started with the first question quickly. Now let me also tell you about BEL. Okay, the last of the exam in the BEL that was conducted, okay, was in 2018. Okay, prior to that it was 2014. Okay, and going through the previous papers of BEL, we can just analyze and realize that the questions are actually very simple. Okay, questions are actually very simple. Okay, of the ESE pre-level, okay, GATE 1 mark level. This is what, I'm just telling you the level. I'm not telling that, yeah, sometimes some direct GATE questions will also be repeated, but okay, even they are repeated or not, that's a different story. But the level is mostly GATE 1 marker. Hardly there you will find a question of GATE 2 marker level, okay, and ESE prelims type question. That is what is the level. Very easy level it is there for the technical as well. Okay, start karte first question ke saath. Many of the questions will be direct, and on same line only we have prepared the mock test. Okay. So, a unity negative feedback system is as shown in the figure. What is the value of the damping ratio and settling time for 2% tolerance? What is the value of the damping ratio and settling time for 2% tolerance band? Morning, Bhanu. So they haven't announced that, Banu, they'll be announcing the exam pattern and all exam details soon. So I'll update you once it is out. Okay, so chalo guys, mostly they won't allow, but yeah, let's wait for the exact pattern. Okay, so unity negative feedback system is as shown below. What is the characteristic equation? Quickly, I will just start with the characteristic equation. 1 plus GSHS equal to 0. So overall forward path gain, these two are cascaded, so please multiply them. So I will be getting 49 by S plus 14, right, into HS, which is unity feedback. Okay, HS is 1. So, you know, solving from here, S square plus 14S plus 49 equal to what? Equal to the 0. So I can say that the value of omega n square is 49, because this is the term omega n square. Omega n is 7, and this term corresponds to 2 zeta omega n. Out of that, zeta nikalna hai na? So out of that, omega n obtained is 7. Okay, so 2 into 7, 14, 14, 14 cancelled, and the value of zeta is equal to 1, meaning that the system is critically damped. Okay, now zeta equal to 1, system is critically damped. What is the settling time now? Now I see mistakes coming up. I already see mistakes coming up. What is the settling time for a critically damped system? You are using the formula maybe for an under damped system. Okay, for a critically damped system, what is the settling time formula? It is 6 upon omega n. 6 by zeta omega n, or simply 6 by omega n, because zeta to 1 hai. 4 upon zeta omega n is strictly for under damped system. Okay, so 6 by omega n ka value 7 hai, and solving this, okay, 0.86 approximately you should be getting. 6 by 7, approximately 0.86. Option number B will be your choice. Okay, you might have done 4 by 7 and landed at option number A. That is wrong, because 4 upon zeta omega n, it is the settling time for under damped. Okay? Next question, guys. The transfer function of a system has been given to you. Okay, comment on stable, whether system is stable, unstable, marginally stable, or marginally unstable. I think marginally stable itself is okay. Okay, if it is marginally stable, so marginally unstable. But yeah, this is the transfer function of a system. Actually, open loop transfer function. Open loop transfer function of a system is given to you. That is to be specified. So what is the characteristic equation? The characteristic equation here is 1 plus again GSHS equal to 0. Okay, and solving which I will be getting S power 4. Solving this, I will be getting S power 4 minus 2S cube plus 4S plus 2. Now there are two problems here. Do you need to go to the RH criteria? Do you need to go to the RH criteria? You can solve it up simply. Okay, you can solve it up simply. Okay, there are two problems here. Okay, number one is this negative coefficient. Okay, the necessary condition itself failed. What is the necessary condition? All coefficients must be of same sign and all the coefficients must be present. Okay, so ye ho gaya negative. And number two problem is S square is absent. That means its coefficient is 0. So clearly indicating that the system cannot be stable. Necessary condition itself failed. Okay, if all the necessary condition is what? All coefficients must be present and neighbors must be of the same sign, right? If that is true, then also we don't ensure stability. Then we go to the sufficient condition, and the sufficient condition is solved in terms of Routh array. Then we check the number of sign changes in the first column of the Routh array. Clear? That's what we do next. Chaliye. Number 3. The Nyquist plot crosses the negative real axis at minus x. Okay. Okay. It was simple. Simple conceptual question. The Nyquist plot, okay, crosses the negative real axis at minus x. Okay, what is the absolute gain margin? I mean, not in terms of decibel, but what is the absolute gain margin? It crosses the negative real axis at some point that is given by minus x. Okay, so I can assume any shade. Okay, maybe something of this kind. Okay, it crosses at minus x. Minus x means, of course, minus x comma 0. So what is the magnitude at this point? At this point, okay, the magnitude of the system will be x. Okay, it passes through minus x, but the magnitude is x. And what is the gain? What is the gain margin then? Okay, this itself represents phase crossover frequency, and gain margin is given by 1 upon absolute gain margin without taking the log, 1 upon the magnitude of the system at omega p, 1 upon mod gj omega p hj omega p. Okay, and that is simply 1 upon x, because at the phase crossover frequency, what is phase crossover frequency? When the Nyquist plot will cross the negative real axis. Okay, so that is the phase crossover frequency. What is the magnitude at the phase crossover frequency? It is simply x. So what will be the gain margin? It is 1 by x. Okay, option is gonna be C. Anyways, it won't be negative anytime, because absolute gain margin is 1 upon magnitude term, 1 upon mod gj omega p hj omega p. Okay, in decibel we'll take it as 20 log 1 by x if it is in terms of decibel they are asking. Correct hai? Chalo, yes, correct answer C. Bhanu, Sushma, Ashish Kumar. Okay. Number 4. If a system has 2 of its poles on the negative real axis and 1 pair of pole on the imaginary axis, then the system is what? Very simple. Very simple. But hoga, such simple questions will be there in BEL. Okay, if a system has two of its pole, okay, on the negative real axis, okay, 2 poles on the negative real axis, okay sir, and 1 pair of poles, only 1 pair on the imaginary axis, then the system is okay. If there is a pair of poles on the imaginary axis and none of the pole is in RHP, then the system will be marginally stable. Na? It's just a tick mark question. It's a tick mark question. Correct Shushma, correct Kumar, correct Ashish Kumar. It's a tick mark question basically, right? If there is a pole in RHP, then the system is stable. If all poles strictly in LHP, nothing on the j omega axis, then only it will be stable. Okay, correct Bhanu. Next question, number 5. For a constant gain k, the log magnitude curve in Bode plot. For the constant gain k, corresponding to the constant gain k, what is the log magnitude curve? Okay, corresponding to the constant gain k, by log magnitude curve. Okay. How do you define the Bode plot? 20 log mod gj omega hj omega, and they are telling that gshs equal to k, corresponding to the constant term k. So it will be 20 log mod gj omega hj omega, that is 20 log k. Okay, so what is the Bode plot corresponding to this term? Yeah, if repeated imaginary axis pole, then unstable. But यहाँ पे clearly बोला था a 1 pair of pole. ठीक है आशीष? हाँ जी, 20 log k. Okay, so how does the Bode plot corresponds to this? Okay, 20 log k, it is clearly independent of frequency. Okay, it's just like y equal to constant, a flat line, a straight line, okay, which is parallel to the x-axis and having the magnitude 20 log k, a horizontal straight line of the magnitude. See, this is also horizontal straight line, but option number A के हिसाब से जाएंगे तो it could be horizontal straight line of any magnitude. No, horizontal straight line of the magnitude 20 log k, option number B. Okay, option number B. Okay, due to the constant term, there will not be any inclination. Okay, it will be parallel to x-axis having slope 0. Okay, horizontal straight line, that's what parallel to x-axis. Next, what is the unit impulse response of a first order system having the transfer function? Very simple. Okay, what is the unit impulse response of a first order system having the transfer function? Tell me. Right, so directly see, impulse response of a system and the transfer function of a system, they are what? They are the Laplace transform pair. They are nothing, they are simply the Laplace transform pair. They are known as the Laplace transform pair. Okay, yeah, very simple questions. Most of the questions will be very simple only, Ashish. That's why accordingly, see, this is not gate mock test, that we have taken the questions according to BEL level only. Okay, so that's an advantage. Okay, so 1 upon 1 plus st. Okay, 1 upon 1 plus st is like, if I take t common from the denominator, I will be writing it as s plus 1 by t. Now you have to see whose Laplace transform is this? Okay, whose Laplace transform is this? 1 upon t the constant hai, 1 upon s plus a. 1 upon s plus a is the Laplace transform for e power minus at. Okay, so e power minus at. A ka value 1 by t, so e power minus t by t whole multiplied by 1 by t, option number C. It is going to be option number C. Yeah, correct answer Bharat Raj, correct Ashish Kumar. It's option number C. Done? Okay, next question. Consider an LTI system that have a time response to unit step input given by 1 minus e power minus t ut. Okay, that have a time response to unit step input. Okay, the response to unit step input is given. So from here we can get the idea about the transfer function number 1. Now for a certain input xt, the output is observed to be 2 minus 3 e power minus t ut, where ut is unit step signal. What is the value of x2? Okay, देखो, from this information, okay, from the first information, what is the transfer function of the system? suppose the transfer function of the system, let me write it as, you know, some transfer function GS, and from the first knowledge I have ratio of output to input. What is the output? 1 minus e power minus t. Laplace transform, 1 ka Laplace transform 1 by s. E power minus t, 1 upon s plus 1. This is the output Laplace transform. For what input? Corresponding to unit step input. The unit step input means Laplace transform 1 by s. Right. So directly first I am finding the transfer function of the system, ratio of output by input Laplace transform. From the first information, input output is given to me. Okay. So now if you simplify the numerator, s plus 1 minus s, this will be simply 1. So 1 by s, s plus 1 divided by 1 by s. So 1 by s getting cancelled. The transfer function is simply 1 upon s plus 1. Okay. Now let's come to the next picture. For a certain input xt, the output is given to you. Okay. Right, for a certain input xt, ys divided by xs. Okay, ys divided by xs. Okay, what is that certain input? That I don't know. Okay, but transfer function is now known to me, 1 upon s plus 1. Okay, is equal to the next given output. What is the next given output? 2 minus 3 e power minus t. So 2 matlab 2 by s. Okay, 3 e power minus t, 1 upon s plus 1. The Laplace transform for e power minus t is 1 upon s plus 1. It is whole divided by xs. That's the certain input which I don't know. Okay, so we'll just simplify from here. Okay, we'll simplify from here. So 1 upon s plus 1 will be equal to, I just simplify this, 2s plus 2, that is 2s plus 2 minus of 3s, right, upon s plus 1 whole divided by xs. Right, so s plus 1 is getting cancelled. So what is the value of xs? 2s minus 3s, that is actually minus s, then plus 2 whole divided by s. Ye s plus and s plus 1 got cancelled. Okay? Right, so even now if you divide minus s by s minus 1, then plus of 2 by s. Okay, so what is going to be xt then? Okay, this one is little calculative, but that's okay. Ultimately simple here. Transfer function concept you must know. Okay, and Laplace transform. So minus 1 is the Laplace transform of minus delta t, because 1 is the Laplace transform of unit impulse delta t. Okay, plus 2 by s, 1 upon s is the Laplace transform for unit step. So it will be 2 ut. Okay, now what should be the value of x2? Now what should be the value for x2? x2. Impulse will only exist at origin, so forget this. Okay, 2 ut, answer will be 2. Okay, unit step. For t greater than equal to 0, ut will be 1. Okay, so at t equal to 2, its value will be 1. 2 into 1, answer will be 2. Okay, the value of x2 will be 2. Option number D. Correct? Eh? Answer is equal to the option number D. Done? Eh? Next question. Number 8th. Okay, next, number 8th. Here it is. A discrete time sequence is given to you, half power n un minus half power minus n. Half power minus n. So I will actually rearrange. You are given half power n un minus of half ki power minus n. So take the minus power means take the reciprocal again. So that can be written as 2 ki power n. Half power minus 1 is actually 2. So 2 ki power n u minus n minus 1. Okay, what should be the ROC of the Z transform? What should be the ROC for the Z transform? Okay, for this part, a power n un, ROC is mod Z greater than mod a. Mod z greater than half. For a power n u minus n minus 1, left sided signal. Okay, what is the ROC? Mod z less than mod a, that will be mod z less than 2. Okay, now whenever two signals are taken together, okay, you have to choose a ROC which satisfies both. Okay, region of convergence should be satisfying both these Z transforms. I apply both means and intersection, and when you take the intersection, mod z should be greater than half but less than 2, meaning that mod z should be between half and 2. Okay, so answer will be option number D. Half less than mod z less than 2. Okay, yeah, correct. Ashish Kumar, Bhanu Prakash Kumar. Right, correct answer is D. The very correct answer is option number D. Okay, next question. Imaginary part of DTFT of a certain signal is 0 if signal is real and even. That is statement number 1. Okay. Imaginary parts in DTFT of such signals cancel out when signal is real and even. Right. Which of them is true and whether the second statement is correct? Explanation of the statement number 1. Right. Whenever a signal is real and even, whenever a signal xn is real and even, its DTFT is also real and even, right? Very, very famous and important property. The DTFT is also real and even. Acha, ab DTFT is also real, meaning its imaginary part is 0. Imaginary part of the DTFT is 0. Okay, and why it is 0? Yes, definitely, when you consider a real and even signal and solve for its DTFT, okay, the imaginary part calculations actually cancel away. Okay, that is the correct reason also. Imaginary terms cancel away, real part is only left. Okay, you need not derive it, but you should be aware about such facts. Correct. So statement 1 and 2 both are true, and statement 2 is the correct explanation. It is the correct explanation of the statement number 1. Okay. Option number A would be correct here completely. Option number A would be correct here completely. Okay, next. The autocorrelation function Rx tau satisfies which of the following properties? Tell me. The autocorrelation satisfies which of the following property? Okay, some fundamental properties of the autocorrelation that you must be aware about. Yes. Autocorrelation function is always an even function. Autocorrelation function is always an even function. So Rx tau, sorry, I can say that Rx minus tau is equal to the Rx tau. Okay, option number B. Okay, is C also correct? The maximum value of the autocorrelation is obtained at origin, not the minimum. The actual property is Rx0 is greater than equal to Rx tau for any other tau. Okay, ये reverse लिख दिया है. Okay, right. ठीक है? Yes, Ashish. This can be put anywhere, signals or communication, no issues. Okay, but few communication questions I'll also be taking today. Okay, I told you the complete syllabus coverage is there. Okay, so including communication also. Okay, and then EDC, analog, network, digital, all this will be taken by Sanjay Rathi sir. Okay, I'll add on to control, signals, communication, EMFT. Okay, next question guys. Two random variable x and y are to be uncorrelated if their covariance is 0. If covariance is 0. If the covariance is 0, right? What is the covariance between two random variables? The first formula is E of xy minus EXEY. E of xy minus EXEY. Main subject is all. Okay. Main subject is all. Of course, there is little bit more expectation from, I'll tell you, communication, EMFT, EDC, analog, digital. 5-6 subjects from which more expectation hoga, but syllabus complete gate you have to study. EC lover. Hanji. Okay. So now, if the covariance is 0, so this portion should be 0. So option number C. That is the option number C. Yes, all gate subjects, but 5-6 subjects are more important, which I mentioned. I will repeat. Important subjects for BEL. First of all, study all subjects of gate, but important one being, I repeat, digital. Okay, analog. These two will be very important actually, and EDC also. Okay, EMFT, communication. Okay, next question guys. Number 12. An audio signal 5 cos 200 pi t is quantized using 10-bit PCM. What is the signal to quantization noise ratio? Signal to quantization noise ratio. Okay. Okay. What is the bit? Okay, it's a 10-bit PCM. What is the formula you will use? 3 by 2 into 2 ki power 2n. Right. 3 by 2 into 2 ki power 2n. Aptitude to hai. Aptitude they have specified. There are two sections, technical and aptitude. They have specified clearly. Okay, so aptitude to hoga hi. Okay, right. But okay, in today's mock test, we are covering the technical, complete technical. There are two sections in BEL. One is technical, one is aptitude. Technical we are covering. Aptitude anyways, most of the time, most of the Sundays, I am covering some aptitude session for you. This time we have covered the BEL mock test on Sunday. Otherwise, mock test we are usually covering on Saturdays or Friday, but this time mock test we have kept it on Sunday, no issues. Okay, so this is going to be how much? 3 by 2 into 2 raised to the power 2 into 10. Okay, but now options थोड़ा सा यहाँ पे आपको देखना पड़ेगा, slightly in a different format. Okay, you are getting the option answer in the form of 2 power n. Okay, 2 power n. Here it is in the 10 power 6, so no problem. 3 by 2, I can write it as 1.5. Okay, 1.5. Now please see, 2 की power, okay, no need to use calculator, approximately I will tell you. This can be written as 2 power 10 whole square. A power ultimately will multiply, so I can write this as 2 power 10 whole square. Now please see, what is 2 power 10? In binary world, it is approximately 1k. Okay, it is approximately 1k. So 1k into 1k is 1m. It is 1m. Okay, so approximately, it's approximately, because what is 1k? See, 2 power 10 is 1024. That is approximately we write 1k. Na? Okay, so 1k into 1k is 1m. Okay, so this can be approximately 1.5 into 1m, and in the decimal 1m is 10 power 6. So whatever is the answer should be close to 1.5 10 power 6, because they have given the answer in the form of 10 power n. Okay, why it is 1.57? See, whether it is 1.57 या 1.6 you can calculate, but not required. Approximately बोल दिया ना यहाँ पे. Okay, because 1k 2 power 10 is approximation of 1k, so that is why approximately our answer matching. The rest you can do the perfect calculation also, but not required here. Okay, not required here. Okay, see what I told you, एक simple सी language में मैंने बोला ना, complete gate syllabus. Now you know what is gate syllabus. Why you are asking subject by subject? Complete gate syllabus include maths or not? Think about this. Okay, chalo next, number 13. Yeah, before I go to the number 13, okay guys, so also next update is that next MMC for you will be live from 11th of November. So all India Open Mega Mock Tests are now live on the BYJU'S exam prep. Okay, appear in it. Okay, first few tests are multiple mixed subject test. Then there will be text, which is official full gate syllabus. The next test for EC will be EDC. The syllabus for next test for EC will be EDC and analog. If you perform, okay, in these particular tests, you also get a chance, okay, get huge discounts and huge benefits in the BYJU'S complete test series. Okay, chalo. An angle modulated signal is given to you. An angle modulated signal is given to you. Okay, xt 200 cos 200 pi t plus pi by 4. What is the instantaneous frequency? Okay, in terms of hertz they are asking, so I can write down Fi is equal to, okay, Fc plus, in terms of hertz likhna hai, so 1 upon 2 pi d phi by dt, although phi is a constant here, right? So what is this 200 pi by 2 pi? If you divide this by 2 pi, you get only 100, and this part will be 0, because okay, you have the phi which is pi by 4. Okay, so answer is simply 100. Answer is simply 100 here. Okay, answer is simply 100 here. Option number B. ठीक है, done. Correct, Ashish Kumar. Okay, so now let us move ahead to the next question. Okay, here it is. In a communication system, a discrete source generates the symbols from the set ABCD with the probabilities given to you. What is the entropy in bits for this source? Okay, what is the formula you will use for entropy in bits here? Okay, it will be given by negative of summation of px into log of the probability to the what base? To the base 2. Okay, so this is going to be negative of, now what is the first probability? 0.4 into log of 0.4, log taken to the base 2. Okay, then 0.2 log of 0.2 to the base 2, 0.3 log of 0.3 to the base 2, and last one will be 0.1 log of the 0.1 to the base 2, correct? Okay, so yeah, let's complete this calculation, guys. Let us just complete this calculations. Everything will be okay, base 2. Okay, I'll take care of that. Minus 1.85 and minus becomes plus. So 1.85 approximately, option number A. Just check out the calculation once. Okay, it should be coming out to be option number A. Just check out tally the calculation once. Okay, just tally the calculation once. Right, Aji? Okay, just tally the calculations and let me know. And by the time, let us go to the next question. Curl of the gradient of any scalar field is how much? Curl of the gradient of any scalar field, okay, is curl of gradient of any scalar field is 0 always. That's identity of vector, so it's 0 everywhere. Okay, not only at infinity, not only at origin, it is 0 everywhere. Okay, yes, correct, Kumar. Okay, so previous one also others are getting A, Bhanu, Kumar and Ashish. Chalo, great. Yeah, Manoj, correct for this one. Next one. If the 2 ampere current flowing through a solenoid of self-inductance 4, then what is the energy in the electromagnetic field? Very simple, na? Okay, what is the energy in the electromagnetic field? Half Li square. That's it. Okay, L, self-inductance is given to you 4 and the current that is being flowing is 2 ampere ka current hai. So this becomes 16 by 2, 8. Answer should be option number B. Answer should be option number B. Yes, conservativeness. Chalo, done. It's simple, option number B. Okay, done hai. Chalo, done. It's in. Yeah. Option number B. Just second, no, Sushma, it's B. Okay. Calculation sahi hai na? Yeah, 4, 4, 8. Yeah, it's gonna be B. Sushma, just recheck the calculations. Next. Ashish also says A. Huh? Why so, guys? Half Li square L4 hai and I square. Did I do any calculation error? No, it should be B only, na? Yeah, correct. It should be B only, not A. Next one. If L is the length of a conductor lying within the magnetic field and I is the ampere current carried by it, then magnitude of force experienced by it. Okay, what is the force experienced, okay, by a current element of length L? The force experienced, okay, in general is given by the notation IL cross B. Is given by what notation? IL cross B, right? So if you want to talk in terms of the magnitude, A cross B magnitude, mod A mod B sin theta. So it becomes ILB, mod A into mod B into sin theta, where theta of course would be the angle, okay, between the current element, okay, between the direction of the current element and the magnetic field. Correct. So yes, Manoj and Ashish, C, correct answer. Okay, it's C. Yes, correct. Right, this can be derived using Ampere's law, Kumar, as well as Biot-Savart law. Okay, from both it comes up actually. That's okay. C is the correct answer. ILB sin theta can be taken up. Okay. Next question number 18. 3-point charges. Okay, this is a good one. 3-point charges, each of 10 microcoulomb, are placed at the vertices of an equilateral triangle that has the sides 15 centimeter long. Find the force on each charge. Find the value of force on each charge. Find the value of the force on each particular charge. Come on, tell me. 3-point charges, okay, of 10 microcoulomb each, okay, of 10 microcoulomb each, are placed at the vertices of an equilateral triangle, okay, equilateral triangle that has the sides 15. Okay, so let's say the charges, okay, let's say I call the charge as Q right now. Later on we will use the value. Okay, this is Q. Okay, what is the force on each charge? Okay, it's a symmetrical story. If you calculate force on any one charge, on others also it will be identical. So basically calculate force on any one charge. Now, what is the force experienced by this particular charge? What is the force experienced by this particular charge? Okay, it is going to experience a force due to this side. Okay, due to this particular charge. Okay, let's say, and that force will be repulsive because of the similar charges. That is going to be a repulsive force. Okay, say that is equal to F1. Okay, that is in the horizontal direction. Okay, इसको हम x मान लेते हैं और इसको y मान लेते हैं. तो horizontal means it is in the x direction here. Okay, and due to the other charge at the top vertex, okay, there will be the force. Okay, and that is suppose F2. Now, dear, what is this angle? Dear, what is this angle? This is, you know, first of all, come inside the equilateral triangle. Every angle within equilateral triangle is 60 degree. Okay, so according to the vertically opposite angle, this is also going to be 60 degree. Okay, this is also going to be 60 degree. Now, look into this. There is a force in the horizontal direction, that is x. Usko change nahi karte, but we can resolve the F2 actually. Okay, we can resolve the F2. How I can resolve the F2? So dear, if this is the F2, okay, what will be its horizontal component? Okay, given the angle theta, which is 60 degree, horizontal component is given by mod F, any vector, mod F, okay, cos theta, horizontal component. So that will be mod F cos 60 degree, and there will be a vertically downward component, and that can be written as mod F2 sin theta. Okay, so we can resolve it up. And if you resolve it, acha, number one, whether it is modulus of F1, since I am coming to the magnitude, okay, and modulus of F2, both will be same. Why both the magnitudes are going to be same? Both magnitudes are going to be same? Because charges, see, what is the force? Okay, let us say it is mod F and it is given by K into Q divided by A square, where A is the side. Okay, this distance is also equal to A, this is also equal to A. Here also you are calculating the force between Q. Here also you are calculating the force between Q. The charges are also same and the distance between them same. Isliye modulus F1 will be modulus F2. Okay, so that can be eventually written as K Q square divided by the A square. That is what you can write here. Okay. Correct, Kumar. Okay, so now if you have resolved F2, so what is the total force in the horizontal direction? Okay, one is F1, and modulus of F1 will be modulus of F plus modulus of F. Next one, the horizontal component coming up, modulus of F cos 60 degree. And what is the total vertical force? The total vertical force is mod F sin 60 degree. Okay, now this can be understood as cos 60 degree. Dear, cos 60 degree is half. Okay, so 1 plus half will be 3 by 2. So this is 3 by 2 mod F. Okay, and this is equal to how much? Okay, this will be root 3 by 2 mod F. Okay, so what is the net magnitude of the force? What is going to be, now I have added both the forces along both the components, horizontal and vertical. So what is going to be the net magnitude of the force? Okay, now combine them. You have the total horizontal and vertical vector force available. Okay, so it's going to be square root x square plus y square. It's going to be square root of x square, that is, okay, 3 by 2 mod F ka whole square. The next one is root 3 by 2 mod F and iska whole square. Let me solve it up. That's become, okay, 3 square 9 plus root 3 ka square, that is 3, divided by 2 square 4 into mod F ka square. Okay, so ultimately 12 by 4, 3 under root of 3, root 3, and then mod F ka square under root se cancel. So answer is root 3 mod F. Okay, answer is root 3 mod F, where what is mod F? Okay, K is given by 9 into 10 power 9. Okay, into Q square. What is the value of Q? 10 microcoulomb. Okay, 10 micro, so 10 into 10 ki power minus 6 whole square. Okay, is divided by A, and the side is 15 centimeter, yaad rakhna. So that is 0.15, everything in the SI units. Okay, everything in the SI units. Now let's solve it up. What it is going to be, you have root 3 and then into 9. This is 10 power minus 10, cancel with 10 power 9. So only 10 power minus 1 will be left actually, and then divided by A square, 69.28. 69.28 newtons of the force. Please check this. 69.28, and yes, here we have option number C ready for us. 69.28, option number C is the very correct answer. This is a good question, okay, but you can solve it up by resolution of forces in little less time. Okay, if you solve, by writing the force with respect to coordinate, writing every force in vector form, that also can be done. Okay, taking the coordinates of the 3 points, but that will take little bit more extended time. Okay, that will take little bit more extended time. Okay, so done. So that's what, paper. Most of the questions, 90% questions are saying very simple, straightforward. One or two, some calculations can also be involved in 1 or 2 questions. Next, number 19, if the supply frequency increases, then the depth of skin effect. Okay, skin depth basically. Okay, skin depth delta is always proportional to, okay, 1 upon square root of frequency, inversely proportional to the square root of the frequency. Okay, so skin effect, dominant in conductors actually. So if I want to write down the formula for the skin effect of good conductors, it is given by, formula for skin depth, it is actually given by 1 by alpha, and that will be 1 upon root over pi f mu sigma. Actually, that is the complete formula. 1 upon root pi f mu sigma. So definitely supply frequency increase, skin depth will decrease. That is option number A. Option number A. Okay. That is the option number A. Okay. Next, number 20. In electromagnetic field, which one of the following does not satisfy the wave equation? Okay. Now, what is the wave equation you can write here? Okay. Assuming the wave is traveling in X or Y or jo bhi coordinate, in some options they have given Z, in some they have given Y or X. Okay. So, if I assume any one direction, suppose Z, I can write down del 2E by del T square should be C square del 2E by del Z square. Correct? That is what you can write down. Now, its solution. Now, there is one way. Check each of them, substitute here. Oh, and see which of them satisfies. C is actually the speed, but C could be any constant here. Okay, because it's not talking about that the wave propagation in free space so that you get the exact velocity of light. But C is any constant here while satisfying the wave equation. But you should also know its solution is of the form. Okay, ये मैंने Z लिया है तो Z plus minus CT, right? Or its solution is telling its solution is any function of the form X. Any function of the form of Z plus minus Ct, or it could be any function in the form of omega t plus or minus beta z. Okay, that is what, once you have studied wave equations, once you have studied wave propagation, once you have completed the electromagnetics, so this can be directly known to you. So definitely option number A resembles wave equation omega t minus beta z. This is also omega t plus beta z. Option number C, okay, if you want you can test, but that is actually representing standing wave. Okay, when the time and distance, when the time and space functions sinusoidally are broken into two different functions. Okay, option number D, just verify, I've given you the hint. Option number D, okay, will never match up this equation actually. Okay, because when you differentiate with y, you are going to get a function of y cos y square plus 5t, 2y. Okay, then once you again differentiate, 4y square. So it will not be a constant, it will be a y term coming up, very clear. Ask me if you have any doubts, but D is going to be the option which doesn't match. Okay, C भी match होगा, and I'm just telling you add on that C is actually the type of the standing wave equations that come up. Okay, equation for standing wave, that also is eventually a wave, not a traveling wave, but ultimately standing wave is also a wave. Next question, number 21. E field of a uniform plane wave propagating in dielectric medium is given to you. Okay, what is the dielectric constant of the medium? What is the dielectric constant of the medium? See, normally the amplitude term is 20 e power minus alpha z. 20 e power minus alpha z. That is not mentioned. So clearly it is lossless medium. Clearly it is lossless medium. Because there is no exponential term. Because if it is a lossy medium, there will be attenuation given by e power minus alpha z. Achha. Now, because it is a lossless medium, beta is given by the formula omega root over mu epsilon. Okay. Now, 20 cos omega t, this is omega, minus beta z. Okay. You can just compare this whole particular term as omega t minus beta z, correct? Right. So, what is the beta? Beta z, beta is actually 1 by root 3. Is equal to omega 10 power 8 into root over, let's say mu will be mu naught and epsilon will be epsilon r epsilon naught, and that is what epsilon r, relative permittivity, or also known as the dielectric constant of the medium to be determined. Nothing is mentioned about magnetic properties. So of course it will be a non-magnetic medium. Mu will be taken as mu naught directly. Okay, so now I am left with 1 by root 3 is equal to 10 power 8 root over epsilon r root over mu naught epsilon naught. Now what is root over mu naught epsilon naught? What is the root over mu naught epsilon naught? That is actually 1 upon speed of light. That is actually 1 upon c. 1 upon 3 into 10 power 8, because from that only we calculate the speed of the wave in free space. Okay. So I write this as 1 upon 3 into 10 ki power 8. So 10 power 8 got cancelled. What is the value of root epsilon r? That will be 3 by root 3. So that is again root 3. So what is the value of epsilon r? That is equal to the 3. Option number C. The value of epsilon r is 3. Option number C is very correct. Option number C is the very correct option. Done hai ji? Okay, done. Next question number 21. Transmission line shown below has the characteristic impedance of 50 ohm. Find the input impedance at the source end. Here, find the input impedance at the source end. Okay, and both there are first lambda by 4 section, another lambda by 4 section. In between there is another line in parallel connected. But whenever there is a lambda by 4 line, quarter wave line, what is the input impedance formula you take? Okay, very simple and very important, very frequently asked formula, Z0 square by ZL. It will be given by Z0 square divided by ZL. It is given by the Z0 square divided by ZL. Z0 square divided by ZL. Okay. So for a lambda by 4 line, it is Z0 square divided by ZL. Done, done, done. Okay. So what is the input impedance at this point? First of all, what is the input impedance at this point? उसी को Zn dash बोला है. Okay, and that is given by Z0 square. Now the characteristic impedance of line is 50. Okay, 50 square divided by ZL. ZL is also 50 here. So 50 get cancelled. I have 50 ohm. But okay, what is this impedance? Zn double dash. That will be equal to Zn dash. That is 50. Okay, so these two, you know, what you see, what is the characteristic impedance of this line and all, what is the length of this line is not mentioned actually, but they have given, okay, whatever be the section of line, its input impedance will be equal to Zn dash. Okay, so that means your equivalent picture would be of this kind. Your equivalent picture would be something of this kind. Okay, you have two lines of 50 ohm in parallel. You have two lines of the 50 ohm each in parallel, and yeah, okay, say let's say this is Zn dash, iska value 50 tha, and this is Zn double dash equal to Zn dash, that is also 50, and this is where I need to calculate the final input impedance. The Z0 of this line, okay, is mentioned as 50 ohm. Now very clearly, okay, these two are in parallel. Okay, and what is R parallel? R is R by 2. The 50 parallel 50 will be 25 ohms. So further, what is going to be the Zn then? Further, what is going to be the Zn? Again, a lambda by 4 line is there. This length is also lambda by 4. Okay, so for a lambda by 4, Z0 square by ZL. Okay, again you will use the formula Z0 square by ZL. Z0 is 50 divided by load. So the effective load impedance after solving for parallel is 25 ohms. So divide by 25. So 50 and 25, 2 into 50, 100 ohms. So Zn will be 100 ohms. Correct final answer is option number C. Option number C. Done? Correct final answer is option number C. Okay, next question. Yeah, if the diameter of the antenna is 100 and its frequency is 50, then what will be the far field distance? Okay, Fraunhofer-Fresnel region pe ja raha hai. Far field distance, come on. It's question number 23. Yeah. Yeah, so let's move ahead. So what is the far field distance, dear? The far field distance greater than 2d square by lambda. Okay, distance greater than 2d square by lambda. Lambda you can calculate as c by f, that is 3 into 10 power 8 divided by the frequency, that is 50. Okay, so ye liya 300 by 56 and 10 power 6. 6 into 10 power 6 should be left out. Okay, yeah, 6 into 10 power 6. So now this will be equal to 2d. D is the largest dimension of the antenna, which is the diameter here, divided by 6 into 10 raised to the power 6. 2 by 6, 1/3. 10 power 4 or 10 power 6. So 10 power minus 2. Okay, so 0.6 33, 10 power minus 2 to 0.0033. Option number A, approximately 0.003. Correct? Yes, Bhanu, correct. Okay. Yes, you can check all your faculties in the app directly. Respect. Emmy. Which one of the following is not correct in Maxwell's equation for the time varying field? Final Maxwell's equation for the time varying field. Okay. Del dot D equal to rho V, correct, coming up from the Gauss law. Del cross H is equal to J plus del D by del D. J plus del D by del D. Okay. Ampere circuit law, modified Ampere circuit law with the introduction of the displacement current. Okay. ये भी correct है. Okay, integral B dot ds over a closed surface is always 0. Yes, the flux crossing any closed surface is always 0. Okay, del dot E equal to del B by del T? No, del, the actual correct Maxwell equation is coming up from the Faraday's law. Okay, I'll write down that correct. So which of the option is not correct? हमें तो ये choose करना था. So option number D is correct and the actual is del cross E. Electrostatic field is not conservative in the time varying situation. If it was a static electric field, del cross E is 0. But for time varying situation, it is given by del cross E given by negative of del B by del T. Negative of del B by del T. Okay, that is the correct Maxwell's equation that was coming up from the Faraday's law of electromagnetic induction. Right. Chalo, next. Number 25. A 6 cross 4 centimeter rectangular waveguide operating in the TE32 mode. Dimensions be given hai. Okay, at frequency equal to 2 root 2 times the cutoff frequency, find the operating frequency. Okay, find the operating frequency which is clearly mentioned 2 root 2 times the cutoff frequency. So what you need to do? Right, what you need to do? No, even if curl D, Kumar, that negative sign is missing. Del cross E is negative of del B by del T. Okay. Okay, Kumar, yeah, great. That's what, the reason we bring mock test is just to tell you level of exam and of course to give you additional practices. Okay. So guys, if you have, this is the 25th question, Sanjay Rathi sir will be joining soon, and if you have really enjoyed the mock test till now, if you're getting the confidence, do not forget to hit the like button. Okay, put your attendance, put your response. It's just like your attendance, showing your response, showing your attentiveness. Do not forget to hit the like button immediately. Okay, and put your attendance. So find the operating frequency, which is 2 root 2 times the cutoff frequency. So what my focus should be? Calculate the cutoff frequency. Calculate the cutoff frequency, and cutoff frequency will be calculated by the formula. Of course, we'll take it to be air filled. Okay, the general formula is u dash by 2, okay, under root of m by a whole square plus n by b whole square. This is the formula for rectangular waveguide. Right, ab yahan pe, okay, take the u dash, okay, air filled hoga. So u dash will be equal to c. U dash is the velocity of the wave if it was traveling in the open dielectric. So air assume करेंगे तो air में velocity 3 into 10 power 8 then divided by 2 root over of m 332. तो m is 3, mn mode होता है 3 divided by 0.06. So again be careful, the dimensions are in centimeter but you have to convert into the SI units. Okay, plus 2 by b and b will be 0.04. Okay, so how much this should be turning out to be? 1.5 is multiplied by 10 power 8. Okay, and then you should be having, okay, 350 square, or yeah, again 200 by, so that is also 50 square. The 50, it's actually 50 square plus 50 square. I think I'm okay. 300 by 650, 200 by 450, correct. So 1.5 into 10 power 8 under root of 50 square plus 50 square, 50 root 2. Okay, ये हो गया 50 बाहर आ गया, 1 plus 1 2 root 2, 50 root 2. Okay, so now what is the operating frequency? It is 2 root 2 cutoff frequency. So don't solve further because root 2 cancel हो जाएगा. Okay, so you will have 2 root 2 into 1.5 into 10 power 8 into 50 root 2. Okay, so 2 into 50 देखो 100, root 2 into 2 will be 2, further 1.5 into 10 की power 8. So how much it is becoming? 1.5 into 2, 3 into 10 raised to the power 10 hertz is the answer, or we can put it as 3 into 10, 30, 10 power 9 giga. So 30 gigahertz should be the final answer. Option number B. Option number B. Yeah, correct, Ashish Kumar, Bhanu Prakash, correct answer. Option number B. Okay, 30 gigahertz. Option number B, 30 gigahertz is the very correct answer. Okay, G. Okay, guys. So, for whatever questions we have discussed, the complete question and solution, whatever we have discussed, I'll share you the PDF in Telegram. Okay, it's going to be password protected, and let's have the very simple password BEL as per the exam. Okay. Okay. No, Ashish. Okay, so password will be very simple, BEL. Okay, so guys, you can also download the BYJU'S exam prep app if you want more and more practice about around BEL or around GATE, every exam of your domain, technical exam of your domain. Okay, you'll get lots of practice sessions, practice quizzes, live sessions, and in the quiz format also you can appear at any time. Okay, so you can get this BYJU'S exam prep from the app from the Google Play Store, or you can directly download using this video. There is a link in the description. You can directly download using it. Also, guys, the GATE 2024 crash course is available on the BYJU'S exam prep app. So those who are targeting 2024 and you want the complete syllabus coverage in the fast track manner, but with all variety of question practice. Also, guys, if your target is 2025 or 26, so vision courses for 2025 and 26 complete detailed courses are also now live on the BYJU'S exam prep app, and there are two types of batches available, English also, Hindi also. You can choose any of your batch as per your convenient language. Okay, so you'll have live classes, you can also have recorded lectures, study material, mock test, practice quizzes, everything, okay, under one umbrella by your favorite faculty team. Okay, so you can also I'll just share you the Telegram link where I'll be sharing you the PDF. Just a second, and then I'll invite Sanjay Rathi sir to continue here from question number 26 to question number 51. Here it is. So this is the link of the Telegram. You can join here. I'll be sharing you the PDF, the password protection, BEL. Okay, guys. So yeah, let me call upon Sanjay Rathi sir.
Hello everyone, how are you guys? This is Sanjay Rathi and this is the BEL, that is Bharat Electronics Limited mock test about complete syllabus, guys. Okay, so I think everything is fine now. So guys, already Rakesh sir has solved some important numericals, important 25 numericals. Okay, now I will take some questions from very important subject like EDC, analog, network, digital system. So are you ready to solve next 25 questions? Yes or no? Please give me comments. Yes, everyone. Everything is fine. Very good afternoon, Ashish Kumar and Bhanu Prakash and Kumar. Everyone. Okay. Without any delay, this is my introduction. Myself Sanjay Rathi, I am an ex-IES and I am having around 23 years of teaching experience. And these are my ranks in engineering services exam, guys. And I have trained more than 1 lakh students for competitive exams like ESE, GATE, BEL, ISRO, DRDO. So according to my experience, just after this session, you can solve some important numericals from engineering services previous year question for BEL exam and 1 mark question from GATE exam. Right, but very simple questions, numericals, simple numericals, or mainly theory based questions, guys. Okay, then this is my Telegram channel, that is Electronics by Sanjay Rathi, where I will upload the PDF of this session. Okay, so please you can join this Telegram channel if you want the PDF, if you want the notes of other subject, or if you want to clear some doubts, notification about the exams, then that is for you, Electronics by Sanjay Rathi. And before starting the session, I want to give you one important information, that is today you can participate in National Scholarship Test, right? 90% off on our program. Link is given in description. Register now, and just after this session you can go for mock test. This is a test, scholarship test, okay? And you can start your journey with us. Second important thing, roadmap to secure AIR under 100 in GATE 2025. If one student is from 3rd year, if you want to start your journey for GATE 2025 and engineering services exam 2025 and so on, then this is workshop for you by Joshit Singh sir. on 8th of November at 7:30 p.m. To note the time. Okay, then first question, everyone try to give me the answer for this one. What is the answer for this question, guys? And already Rakesh sir have taken the class, to like the session, share the link of this session so that student will join. और अगर आपने सब्सक्राइब नहीं किया है तो सब्सक्राइब कर लीजिएगा चैनल, बहुत सारे इंपॉर्टेंट सेशन आने वाले हैं. हम लोग कुछ सॉल्व कर रहे हैं क्वेश्चंस फ्रॉम स्टैंडर्ड टेक्स्ट बुक लाइक साडिकू एंड व्हाट आफ्टर दैट आई विल स्टार्ट सॉल्विंग क्वेश्चन फ्रॉम सेड्रा एंड स्मिथ. ओके, देन an operational amplifier has an open loop gain of this 2 into 10 to the power 5. Its output exhibits saturation at 10 volt. The threshold differential voltage of the amplifier. Threshold differential voltage of the amplifier, guys. So that is a very, very basic question on operational amplifier. Now, what is the answer? Watch this. If this is the operational amplifier, then this is called difference gain, VD or VID. Now, what is the gain? 2 into 10 to the power 5. And what is the saturation voltage? 10 volt. So what voltage we can apply here so that it will reach to what? Saturation. That is called what? Threshold differential voltage. So threshold differential voltage, that is the V0 is equal to AVVI. When it will reach to what? Saturation. Saturation means 10 volt. At what point it will reach to saturation? 10 divided by AV. 10 volt divided by, what is the AV? 2 into 10 to the power 5. Then it will become 10 by 2, that is the 5 into 10 to the power minus 5. Or you can write 50 into 10 to the power minus 6. That is equal to 50 microvolt. 50 microvolt. If suppose we are giving only 50 microvolt, then it will enter into what? Saturation. And that's why, guys, what we are doing, we are reducing the gain of the operational amplifier by applying the negative feedback, because the range of the input is very, very less. For very, very small input, it will enter into the saturation. Answer A is correct. Now, next question. Okay, tell me that all the filters are important, and that's why I have taken one question from the filter. Tell me, the following operational amplifier circuit is low pass filter with cutoff frequency 1 by R2C, low pass filter with cutoff frequency 1 by R1C, high pass filter with cutoff frequency 1 by R2C, and high pass filter with cutoff frequency 1 by R1C. Tell me, Manoj Kumar, what is the answer for this question? Okay. C, high pass filter with cutoff frequency. Okay. Now, remember, if we are using operational amplifier here, this is R1, this is R2, this is C, then it is a high pass filter. It is a high pass filter with cutoff frequency. Always remember, this is the case. So what is the cutoff frequency in a radian per second? It is given by 1 by R2C radian per second. Or if it is asked in hertz, then omega C by 2 pi hertz. Okay. And then second important thing, what is the maximum gain? Where we are going to get the maximum gain? The maximum gain you will get at infinite frequency. At infinite frequency, this capacitor will act as what? Short circuit. So this is 0. So capacitor acts as short circuit, and what is the maximum gain? R1 by R2. The magnitude of the maximum gain is R1, that is the normally called RF, R1 by R2, and that is the answer. Maximum gain. And exactly at omega equal to 0, this capacitor will act as open circuit, and that's why the gain will become 0. Gain will become 0. So we can say, it will pass the high frequency signal and it will block the low frequency signal, and that's why it is a high pass filter. Okay, Kumar, your answer is correct, minus R1 by R2, right? High pass filter, because it will block the low frequency signal, it will pass the high frequency signal. Next question. Reduction in gain of RC coupled amplifier at high frequency is caused by. Remember guys, what RC coupled amplifier is very important topic for this type of exam, like what BEL exam. Okay, and get the idea about the frequency response of RC coupled amplifier. Complete idea about this. Tell me what is the answer for this question. Quickly try to give me the answer. The reduction in gain of an RC coupled amplifier at high frequency is caused by, then remember, this type of response of RC coupled amplifier, it is just like a band pass filter. This is called FL and this is called what? FH. So there is a fall in the gain at low frequency as well as fall in the gain at a high frequency, both. Then what is the answer? Difference in transition C. Okay, now watch this. Because of at high frequency means the reduction in the gain of the RC coupled at high frequency means this reason. At a high frequency it acts as what? Low pass filter. Or at a low frequency it acts as what? High pass filter. What is the diagram here? Watch this one. RC coupled amplifier means this is the RC coupled amplifier. Remember this diagram. This is called bypass capacitor. Now this is called coupling capacitor, CC1, and that is called coupling capacitor CC2. Here we are connecting the RL and here we are taking the output. This is RC, this is VCC, this is R1, and that is what? R2. Right? That is the diagram. Now at the same time emitter junction is forward bias and collector junction is reverse bias. Because of that we are getting the internal capacitance, that is called diffusion and transition capacitance. Now at a low frequency gain fall due to what? CC1, CC2 and CE. This is the gain fall CC1, CC2, CE. But at a high frequency gain will fall because of what? Internal capacitance. What are the internal capacitance? Diffusion and transition, wiring, stray capacitance, not because of the coupling capacitor. Are you getting my point, Bhanu, Kumar and all other students? Yes, that is clear. So junction capacitor, because of the junction capacitor, internal capacitance. And why we are getting the internal capacitor? Because the BJT is in active region. When the BJT is in active region, this junction is forward bias, that junction is reverse bias. Because of the forward bias, we are having the diffusion capacitance. And because of the reverse bias, we are having the transition capacitance. The answer for this question is B. B for Bombay. Okay, and always recall, so that you can very quickly you can solve this question. What is the high frequency model? Which model is used for high frequency? Pi model is used for high frequency as well as low frequency analysis. This is the R pi. Here we are having the capacitor, that is called diffusion capacitance. Here we are having the transition capacitance. This is GMV pi. And then this is R naught. Here we are connecting the RL. This capacitor is called C mu. This is nothing but transition capacitor, or it is also called COB. CC, it is also called capacitor between base and collector. This is the emitter, common emitter configuration. This is the base. This is called base spreading resistance. And that voltage is called V pi. This capacitor is also called C pi. This is also called CE, emitter junction capacitance. Now, This is the model. Always recall this model. Always recall. Assis, what is your differential and transition capacitance? Yes, your answer is correct. Yes, yes. You have given the answer. Yes, diffusion and transition capacitance. That is the answer B. Internal capacitance. Yes. Okay. Okay, Assis. Now, watch this. This is the model at high frequency. Means what? Pi model is applicable for low frequency as well as high frequency. And that is also called Geico-Leto model. Geico-Leto model. That type of question in BEL exam they will ask. Geico-Leto model. Normally in GATE exam they will not going to ask you the name of the circuit and so on. But in BEL exam they can ask. So remember what is the difference between the GATE and BEL exam. Okay, next question. This is the model at a high frequency. We can't use what H parameter model at high frequency. We are using this pi model, hybrid pi model at high frequency as well as at low frequency. Right. So what is the purpose of coupling capacitor? Just I will explain in other session, but okay. The purpose of the coupling capacitor is to block the DC signal. That's why it is also called DC blocking capacitor. As well as at the same time it will pass the AC signal. AC plus DC, it will block the DC and it will pass the AC, it will couple the AC, and that's why it is called coupling capacitor. Value is very, very high. Value of all the coupling capacitor and bypass capacitor should be very, very high. Yes. Now next one. The answer is B. Next question, guys. The overall decibel voltage gain of multi-stage amplifier is. Multi-stage is again very important for this type of exam. Because operational amplifier is multi-stage amplifier. Tell me. For overall gain, if it is given in dB, then what is the overall gain of the multi-staging? Multi-staging means cascading. Cascading means when the output of one become input for the other. Then, so are you enjoying the session? To everyone give me the comments. You want this type of sessions more on mock test, on BEL exam or all other competitive exams, guys? How many students want regular mock test? Quickly, देखो, otherwise क्या, we will we want to use this Sunday effectively or this Deepavali effectively, right? So बहुत fast with always remember, with one question we will try to give the idea about that topic, right? Not only we are going to solve that question, so you will get more idea about those topics. For example, in previous question. Okay. Okay, Ashish. Thanks for your comments. Then tell me the overall decibel voltage gain of the multi-stage. So if it is normally it is given, then you can directly find what A1 multiplied with the A2 multiplied with the A3. If it is not in decibel, so the product of dB, that is wrong. So in dB, if suppose that is the in dB, what we are giving 20 log of A, overall gain is given by 20 log of A1 plus 20 log of A2 plus 20 log of A3. If always remember, if it is given in dB, for example 20 dB, 30 dB, 40 dB. So what is the overall gain? 20 plus 30 plus 40, 90 dB. So you have to add 20 plus 30 plus 40, that is the 90 dB. Which answer is correct? Sum of dB voltage gain of the individual stages. C is the correct answer. C is the correct answer for this question. Okay. The next one. Next question. RC coupling is used for amplification of RC coupled, whether it is BJT or MOSFET. Very, very important one. Resistor capacitor coupling. For example, with MOSFET. Tell me, what is the purpose here? Main purpose. You can use the capacitor here also. Coupling capacitor. Bypass capacitor. This is with MOSFET, that was with the BJT. Now, RC coupled is used for amplification of what? Mainly for voltage. Mainly for what? Voltage amplification. And RC coupled amplifier is what? Audio frequency amplifier. Audio frequency amplifier means from 20 hertz to 20 kilohertz signal. And we are doing the multi-staging. So when we are connecting the two RC coupled amplifier means it is basically a common emitter configuration. Normally when we are designing the RC coupled amplifier, single stage RC coupled amplifier, then we are designing with what? Common emitter configuration. For common emitter configuration, the phase shift is 180 degree. Get all the points related to RC coupled amplifier for BEL exam. Then next. Out of the following 4 hybrid parameter, which has the lowest value? Hybrid parameter model, guys. Which one has the lowest? So, when this question, so just in your mind, what is the hybrid model? No doubt it is not in the syllabus of GATE exam, but last year in GATE exam again there was one question on a hybrid model. Recall this hybrid model in what analog? We are having the 2 dependent sources here. And then this is the hybrid model. HOE, HIE, HRE, VCE. This voltage is called VCE. This is the emitter. This is the collector. This is base. This is what emitter. This is the VBE. This is called IB. Then this will become HFE-IB. And this has become HRE into VCE. HRE into VCE. This is the hybrid model for common emitter configuration. Common emitter configuration. Small signal model, linear model. Small signal model, linear model. So Kumar, you are giving the HRE, right? Now we will check. Typical value is, everyone check. HIE is what? 1.1 kilo ohm normally. That is 1100 ohm. Very high value. Then HRE typical value is 2.5 into 10 raised to power minus 4. It is unitless. It is a reverse voltage gain. It is unitless. HFE is very high value. That is also called beta 50. HOE. HOE is what? 1 by 40k. It is in Siemens, mho, ohms. Output admittance. And what is the 1 by 40k? 1 divided by 40,000. And you will get 2.5 into 10 raised to power minus 5. Now, out of these, which one is the lowest value, Kumar? Which one is the lowest value out of these 4? So, you will get HIE 1100, HRE, HFE and HOE. HOE is the lowest one. D is the answer. And these are the typical values of HIE, HRE, HFE and HOE. In early fact, we are just neglecting the HRE and HOE. In simplification, we are taking at 0. So they are just make it short circuit, make it what? Open circuit, and that is called simplified hybrid model. Okay. Now, these are the 2 parameters because of early effect. The next one. Okay. So this answer is D. D for Delhi. Remember values. Then next question. The intrinsic impedance of free space is approximately. Already sir have taken. Yes. HOE is highest in, no. It is not in highest in mho. It is Kumar. What is the value? What is the value here? It is in mho or Siemens. 1 by 40k, and that's why conductance is very low, resistance is very high. So we are taking what? Conductance. This is the output admittance, right? So this is the output admittance. Now the intrinsic impedance of the free space is approximately 120 pi, that is the 377 ohm. 377 ohm. Yes, Bhanu, Manoj, you have given the right answer for this question. So that is the 377 ohm, guys. The next one. So this type of very quickly you can solve the question, but normally students are doing what? Silly mistakes. Just like in a previous question we have done the silly mistakes. Okay. Then So this is the correct answer, 377. Now 120 pi. The diffusion current in PN junction is, what is the diffusion current in PN junction? PN junction, we are designing the diode by using the PN junction. Tell me, what is the diffusion current? There are 4 options. This is the P, this is N, this is the junction, depletion layer is here, and then acceptor, donor, it will donate 1 electron, it will accept 1 electron. Then diffusion current in PN junction is, what is this? Now this is the question from EDC. Diffusion current means, remember, the diffusion means what? Migration of charged particle from higher concentration to what? Lower concentration, right? Higher concentration to lower concentration. So this side, what is the concentration of P? P is nearly equal to Na, because here we are giving the Na doping, here we are giving the Nd doping. And what is the concentration of N here? Nd. But what is the concentration of electron holes here? According to mass action law, it will become Ni square by N, that is Ni square by Nd. Or here the concentration of electron will become Ni square by P, that is Ni square by Na. Here the concentration is very, very large as compared to this concentration. Then P is very, very, very greater than Pn. That's why the hole will diffuse from P side to N side. Hole will diffuse from P side to N side, and the current will be in the same direction from P side to N side. And at the same time, the electron will diffuse from N side to P side. That is the direction of the electron. Electron will move in this direction, because at this point the concentration is high, at this point the concentration is very low, but the charge of electron is negative. That's why the current will be in this direction. That is the current because of electron, that is the current because of the hole, and both are diffusion current, and that is the current from P to N side only. P to N side. From N side to P side, not possible. That is only drift current under the influence of the electric field. That is called reverse saturation current. And from the N side to P side, if the junction is forward bias, and in the opposite direction if the reverse bias, no. From the P side to N side, if the junction is forward bias, and in the opposite direction if it is reverse bias, that is also not correct. No doubt. When it is forward bias, then P side to N side. But this statement is correct. But the remaining, the statement is wrong. This statement is wrong. And that's why this statement is wrong. This is wrong. This is wrong. And one A is correct one. A is the correct answer for this question. Okay. Next one. The Boolean expression AB, not a question from digital, guys. Question from digital. These are the mixed questions, 25 questions. Tell me quickly. Yeah, this is a very, very easy question, but in exam you can make silly mistakes. Boolean expression AB into A plus C is equivalent to AC, AB, A plus B, or what? A. AB into A plus C is equivalent to, I am waiting for your response, guys. Okay, please go through the theorems and go through the Boolean expressions, everyone, and how many equations are possible, and so on. Everything, get the idea about that. Basically, what about the AND gate, universal gate, NOR gate, NAND gate, flip-flops, basic idea. No need to solve what very lengthy questions like what gate exam. Manoj, you are giving the answer AB. Yes. So what we can do, when AB multiplied with this plus ABC, A dot A, what is the A dot A? That is nothing but A. So it will become AB again plus ABC. You can take AB as a common. 1 plus C. What is the 1 plus C? That is equal to 1. It is what? AB. It is AB. B is the answer. AB, option B, bilkul sahi. That is right. That is correct one. So within 10 seconds we can solve this question. Okay. Then next one. If ones are applied simultaneously to both set and reset input lines of a NOR SR latch, right? So we are designing the by using the NOR gate. So everyone, you can draw the diagram here. This is the latch. Okay, then tell me. Then what is for NOR gate? If there are two inputs 0 0 0 1 1 0 1 1 bar 0 0, you will get, if both the inputs are 0, you will get 1. If any one of the input is 1, then now you will going to get the 0. You will get the 0. If any one of the input is what? 1, then you will get the 0 here. So this is the NOR gate. NOR SR latch logic. Now, then the mode of operation will be, if simultaneously both the set and, this is the set and reset input, set and reset input, if simultaneously you are going to make what, this is 1, then what will happen? The Q and Q bar will become 0 0. Because any one of the input is what, 1 in NOR gate, what will be the output? Any one of the input is 1, then what will be the output? 0. And when just we are removing the trigger, right, we are just remove the trigger, then we are not able to justify that what we are going to get, though, whether it is 0 or 1. So this is prohibited. Is it clear? Is it correct? Yes, please. Everyone. Because it is a simultaneously both set and reset inputs of line of what? NOR latch, not the NAND latch. NOR latch. So trigger, we are giving the trigger, guys, like this. Zero to 1. Simultaneously when we are giving the trigger, that will be the problem. Similarly, for what? NAND latch. So remember, for NAND latch, if A or B, 0 0, 0 1, 1 0, 1 1. Any one of the input is 0, output is what? 1. And both the inputs are 1 1, then output is what? 0, guys. Now for example, if I am putting all the inputs 0, then if this is 0, this is 0. If both the inputs are 0, simultaneously both the inputs are 0, then what is the output? 1 1. Both the Q and Q bar will become what? 1 1. And after that, just when we are removing the trigger, we have no idea whether it is 0 1 or 1 0. That is the meta-stable state. That is again in case of NAND gate, 0 0 is prohibited. 0 0 is prohibited. Is it clear? This is correct? Okay, guys. Now, next one. Next question. In a digital, remember, this is a very, very basic question. In a logic gate, output will be 1 if. In a logic gate, output will be 1 if. Again, from the Boolean function or NAND, from the basics of the gates, guys. In a logic gate, output will be 1 if. You can check all the answers. Anything odd with its own complement. Anything odd with A plus A bar. Odd with. Then what is this? If it is 1 plus 0 or 0 plus 1, it is always what? 1. I think the first answer is correct. Okay, your comments are not coming. Solve. Which answer? Anything odd with itself. Odd with itself means what? A plus A is nothing but A. If it is 0, then 0, then 1 and then 1. We are not getting 1. Logic gate output is not always 1. A is 0, then output is 0. A is 1, then output is 1. Then this is wrong. Anything AND with itself. AND with itself, again A dot A. It is A dot A is A. Same case. And anything AND with its own complement. A dot A bar is always 0. A dot A bar is always 0, and that's why the answer for this question is A. Answer for this question is what? A. But it is easy question, but time consuming. So once you will get the answer A is correct, it is MCQ, guys. Only one answer is correct, then directly you can put, no need to verify all other options during exam. During exam. Then next one. Okay. For a 3-input NOR gate, possible number of states where output is 0 equals. For 3-input NOR gates, possible number of states where output is 0 equals 8, 1, 7, 5. 3-input NOR gate. Tell me what will be the answer. 3-input NOR gate. The possible number of states where the output is 0 equals. So be careful about this type of questions. You can make silly mistakes. So please try to avoid. 7. All other students. Okay then. Then guys, remember 3-input NOR gate means what? 3 inputs NOR gate means देखो 3 inputs NOR gate means what? It is where output is equal to 0 means there are 4 options 8, 1, 7 and 5. So according to this question, what will be the answer? You are giving the Bhanu, you are giving the C answer. Kumar, you are giving the C. Manoj, you are giving the C answer. Okay, 7. So simply there will be 8 combinations 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So for NAND gate, total 8 combination. Out of 8 combination, when any one of the input is 1, output will be 0. So this is the 0. Out of 8 state, only one time we are getting 1, 7 times we are getting 0, and that's why the answer C is the correct one. Very true. That answer is C. Then next one. Before just for next question, just I want to give you one important information, guys. All India Open Mega Mock Test, you can participate in this for GATE 2024 for civil, mechanical, electronics, electrical and computer science branch. But first of all, install BYJU'S exam prep app from Google Play Store, and that link is given in description. Go through it, install it and give just like this type of mock test, guys. Full length mock test for GATE exam, right? And subject wise mock test for GATE 2024. Always remember, the mock test will help you. You will get the idea about the important questions and it will boost your confidence, guys. For on regular interval, you have to give the mock test subject wise, syllabus, half syllabus, full syllabus, right? Full length mock test. This is time to give the full length mock test. Yes, you can join now. Then next one. So for this, you can register here. Link is given in description, and that is what schedule of that. Next question. Which of the following diode having no depletion layer and also known as hot carrier diode? Also known as a hot carrier diode. Question from what? Electronics devices, special diodes. Tell me, what is the answer? Which of the following diode having no depletion layer and also known as a hot carrier diode? PN junction, Stockley diode, step recovery diode, and what? Schottky diode. So you have to get the idea about all the diodes. What is the PN junction diode? What is the Stockley diode? What is the step recovery diode? And what is the Schottky diode? Right? Now tell me. Tell me, guys, what is the answer? Jaya, you are giving the B answer. This is a hot carrier diode when we are talking, and there is a no depletion layer. Because of that reason is combination of what semiconductor and that is the answer is what? Schottky diode. Answer for this question is Schottky diode. It is theoretical question. The next question, theoretical one. To get the idea about all the diodes, please write 1 or 2 lines. Normally we have familiar with the PN junction, Shockley diode, step recovery diode, or what LED, that is light emitting diode, right? LED, that is what light emitting diode. You have solar cell, basic idea about the solar cell. Okay, no problem. Then diode junction breakdowns above 5 volt are caused by. Diode junction breakdowns above 5 volt are caused by Zener effect, diffusion effect, combination of the two effect, avalanche effect. Avalanche effect. Breakdown diodes. We are having the specially designed diodes that works in reverse direction. That is called breakdown diodes. And we are having two types of mechanism. One is called Zener mechanism, one is called avalanche mechanism. And when the Zener breakdown is above 5 volt, so normally it is caused by which? Zener avalanche. What is the difference between the Zener effect and avalanche effect? Then answer, Kumar is giving the D, Manoj you are giving the D. Yes. Now watch this. In Zener, doping is very high doping. What is the avalanche doping? Normal, moderate, low as compared to low or moderate doping. Here very high doping. Here normally the breakdown voltage is less than or equal to 5 volt, and some books it is written as 6 volt. Normally the breakdown voltage is greater than 5 volt. So when we want higher breakdown voltage, avalanche effect. That is called impact ionization, multiplication of the charge carrier, and that is called direct rupturing of the bond. Okay, so these are the difference, and there are further more difference about what? Temperature coefficient, guys. Temperature coefficient means his breakdown voltage is positive. It has positive temperature coefficient, means temperature increases, breakdown voltage increases for avalanche, and just opposite here. dVz by dt is negative here. Negative. So already I have given the difference between the avalanche and Zener. So that is the avalanche effect. For 5 volt are caused by this. Okay. If you want the complete difference between the avalanche and Zener, that will be uploaded on my Telegram channel. That is Electronics by Sanjay Rathi. No. Forward bias is not avalanche. Reverse bias is not. No, that is not the case. In both the cases, Zener diode will be what? Reverse bias. In both the cases, Zener diode will be reverse bias. Whether it is avalanche or whether it is Zener effect, it will break down in reverse direction only. Next question. In the emitter junction, if the emitter junction is reverse bias and the collector junction is forward bias, then tell me which mode of operation. Very simple. Emitter junction, collector junction. What is the mode of operation? What is the mode of operation? Mode of operation here. Tell me. Okay, guys. Inverse active mode, D. Yes. When, try to understand, when both the junction, this is the reverse bias, this is the reverse bias. This is called cutoff. Cutoff is used for switching. Both the junction forward bias, forward bias. This is called saturation. These two are used for what? Switching action. When it is forward bias, it is reverse bias. This is called normal active mode. Normal active mode or forward active mode. Forward active mode. Right. But when this junction is reverse bias, this junction is used as forward bias. This is called reverse active mode or inverse active mode. Inverse active mode. This is also called reverse active mode. Now, inverse region of the transition operation. This is the saturation, active, cutoff, inverse region of the transition operation. That is the D is the answer. But what is this? Inverse and active. Now, what is the use of this? The use of this mode is what? For low amplification. For low amplification. Normally for amplification, we are using the normal active mode or what? Forward active mode. So this is the low amplification. Okay, remember. And in TTL, we find application of this. TTL, transistor logic. Watch the transistor logic diagram carefully. In one of the transistor will goes into what? Reverse active mode. Okay, that is the use of this reverse active mode. Okay, then next question. You have given the right answer, everyone. Sweta, your answer is also correct. Now I think you have subscribed our channel ना, तो अगर नहीं किया है तो please subscribe the channel so that you will get the notification for all coming sessions, guys. Now input to operational amplifier open loop comparator. Open loop comparator means there is no feedback. Without feedback, we are having this comparator. Already we have solved some questions on this. Tell me. This is the comparator. Open loop comparator is a sinusoidal signal. The output of the comparator is. What is the Kumar and all other students? Give me the answer. What is the output of the comparator is? Now, watch this. Here it is a sinusoidal signal if we are giving. Then, suppose we are setting the 2 volt as a reference voltage. This is called reference voltage. And then always remember the output of the comparator is plus Vset or minus Vset. Plus Vset or minus Vset. When this terminal, positive terminal voltage is greater than the negative terminal voltage, you will get plus Vset as the output. And when the positive terminal voltage is less than the negative terminal, you will get the minus Vset. Means sinusoidal waveform is converted into what? Square wave. Sinusoidal waveform is converted into square wave. This is the correct answer for this question. Right? And now I am going to give you the new word also here. Sinusoidal waveform is converted, and sinusoidal waveform is a slow varying waveform. Remember, sinusoidal waveform is a slow varying waveform, guys. And slow varying waveform is converted into fast varying waveform. Slow varying waveform is converted into fast varying because square wave, the change in the square wave is very fast, guys. Watch this. For this is the reference 2 volt. This is the sinusoidal signal. When the sinusoidal signal is less than the reference, output is minus Vset. When it is greater than that, output is plus Vset. Then again minus Vset, plus Vset, minus Vset, plus Vset. So that will be the question square wave. And this is the slow varying waveform, and this is the very fast from minus Vset to plus Vset. Minus Vset to plus Vset. This is very fast. So slow varying waveform is converted into fast varying waveform. Okay, that is the word. And now, guys, what is this? In which mode? This is the MOSFET, operational amplifier is in which mode? Bistable, monostable or astable? There will be the new question on that. Bistable, monostable or astable? Or astable? Tell me. Right. Now next question I am going to start. So before that, try to give me the answer. Okay. Okay, guys. Now watch. This is a rectangular waveform, and remember, when we are designing the comparator, it is a bistable multivibrator. It is a bistable, not as astable. Astable is a square wave generator. There is the output without any input. Right? I am going to take one session on that. Astable multivibrator. Next week in Learn With Fun, you will understand. Lightning for what? Deepavali. So how we can use the astable multivibrator and counter to design the lightning. Right? Now, this is a bistable, and best practical example is what? Schmitt trigger circuit. Schmitt trigger circuit is also a comparator. Then next one. The feedback path in an operational amplifier integrator consists of feedback path in integrator, guys. Think about the integrator diagram. What is the integrator by using the operational amplifier, and then you can give the answer for this question. Integrator and differentiator. Feedback path in an operational amplifier integrator consists of resistor, capacitor, resistor and capacitor in series, resistor and inductor in parallel. Which answer is perfect answer? This is the operational amplifier. This is the operational amplifier. And with the help of operational amplifier, we can design what? With the help of operational amplifier, we can design integrator. Okay. So this is a two cases. This is resistor here. This is connected to ground. And this is the capacitor here. So in a feedback path, we are having the capacitor. This is called integrator. Or for more practical integrator, what we are doing, we are connecting the capacitor here, or in parallel we are connecting the resistor here to make the gain finite. It is also a integrator. This is called practical integrator. This is called practical integrator. Both are the integrator. But here what is given? The feedback path in an op-amp integrator consists of resistor, wrong. Capacitor, that is correct. Resistor and capacitor in series, no. Feedback path, only the feedback path it is asked, not in series. It is in parallel. That should be connected in what? Parallel. C and RF should be in parallel. And the resistor and inductor in parallel, wrong. We are not connecting inductor to design what? Integrator. To design what? Integrator. So this is the wrong, and which answers are correct? Only B option is correct. This is also integrator. You are saying that, sir, for differentiator R and C are in parallel. No, that is the wrong statement, Kumar. Is it clear? It is also integrator. It is also integrated. This is a practical integrator. For this, the gain will become infinite, right, at zero frequency. For this, the gain will become finite at zero frequency RF by R. Because at zero frequency, this capacitor will act as open circuit. Okay, next one. Next question. To get the idea about all these diagram application of the operational amplifier, then again now the question from some questions from what? Network, guys. Now network. Tell me. The superposition theorem is essentially based on superposition theorem. Linearity, duality, reciprocity, non-linearity. Superposition theorem means when there are more than one sources, then we can get the effect of one source by making all other sources zero. Right? In a particular circuit, if there is a more than one sources, then this is a current source, this is the voltage source, then you can get the effect of individual sources by making other sources zero. For example, to make the voltage source zero, make it short circuit. To make the current source zero, make it what? Open circuit. Superposition theorem. What is this? What? Additive and homogeneity. That is what? Linearity. So this is answer is what? Linearity. Very, very basic question. Within 10 seconds, you can give the answer for this type of question. Linearity, just we have to satisfy the linearity and then we can apply the superposition theorem. For example, operational amplifier, it is basic linear integrated circuit, and that's why we are applying the superposition theorem in case of operational amplifier. Small signal models like hybrid model, pi model, so we are using the word small signal because these are linear models to maintain the linearity so that we can apply the superposition theorem, guys. Okay, next one. The depletion layer of PN junction diode is due to. Why we are reading the depletion layer in case of PN junction? Why we are getting the depletion layer in case of PN junction? Here it is a depletion layer. Depletion layer means there is no mobile charge carriers, only immobile charge carriers are present. Here the holes are present. Here electrons are present. What is the basic reason? This is P type, this is N type. Here we are giving the Na doping, here we are giving the Nd doping. Right. Why we are getting the depletion layer? That is because of what? Doping. Yes, we are giving the Na doping here, we are giving the Nd doping here, and when the electron will recombine with the holes, then this is the immobile charge carriers are present, and that is called depletion region, space charge region, or transition region. And there will be electric field from positive to negative. This is the direction of the electric field developed inside the depletion region. It will stop the further diffusion, and that's why in open circuit bar current will be 0. That is because of what? Doping of the material. No doubt, when we are doing the reverse biasing of the junction, then the depletion layer, there is a widening of the depletion layer. When we are making the forward biasing, the depletion layer will reduce. Absence of the current carrier. Absence of the current carrier is the definition of that. In the depletion layer, there is no mobile charge carriers, no electron, no holes. But why? So why is doping? A is the correct answer. The next one. Okay, quickly give me the answer. Next, last 6 questions, guys. Stay tuned with us up to last question. Okay, some important numericals from network. Tell me. This is the question from analog. If the input to the full wave rectifier is sinusoidal signal with the frequency 50 Hz, then the time period of the ripple at the output of full wave rectifier is full wave. It is talking about the full wave rectifier, guys. Full wave rectifier. This is the input given to the rectifier, or in case of full wave, we are getting this type of wave. And this is the output and this is the input. The frequency of the input is 50 Hz. In India, the supply frequency is 50 Hz. Then the time period of the ripple at the output of the full wave rectifier. D option, you are giving the 40 milliseconds. Kumar, all other students, Jaya, Susma, Manoj Kumar, Bhanu, youth, what is your answer? Tell me. Now, I have given you the diagram. Watch this diagram carefully. I think you have to get the basic idea about this. Watch this carefully. This is the sinusoidal waveform. This is the bidirectional. But when we are passing through the full wave rectifier, you will get this type of waveform. Full wave means this is the full wave. Okay. Then this is the time period of the input signal. What is the time period of the input signal? T is equal to 1 by F. So you can find the time period of the input signal 1 by 50. That is divide 20 millisecond. 20 millisecond is the time period of the input signal. Then what will happen? This is a pulsating DC. Pulsating DC means it has AC plus DC both. Pulsating DC means AC plus DC. Now what is the time period? After T by 2 it will repeat. Time period is T by 2 only. The time period of the output is T by 2 only, because after T by 2, T by 2, T by 2 it is repeated. And that's why, and the frequency is double. So what is the time period of the output? T by 2, that is the 10 millisecond only. And what is the frequency? That is called ripple frequency. Output frequency is also called ripple frequency. Why? Because this AC component is called ripple. And what is the frequency of the DC component? 0. So output frequency is nothing but frequency of the AC component. And what is the frequency of the AC component? What is the name of the AC component? Ripple. And that's why output frequency is called ripple frequency, double, 100 Hz. And that's why the answer is 10 millisecond. So my dear friends, we are doing, so always remember, Kumar, be careful about that. In exam, if suppose we are doing the silly mistakes, if we are just losing 1 or 2 marks out of race, be careful. We can't avoid 100% silly mistake, but be careful. First of all, quickly draw the diagram and think about it. And then give the answer. Okay then. Okay, no problem. Now tell me, what is the answer? Arey, don't worry. Be cool here. Don't worry about the results. आप लोग सब perform करेंगे and everybody doing the silly mistakes. Okay. The theorem which states that in any linear, non-linear, passive, active, time variant, time invariant, the summation of the instantaneous power is 0 will be called as. That is the question from the network, from the theorem. all theorems are important, but that is the theorem which can applicable for any type of network. So Susma, you have given the very quick answer for this particular question. Yes. Which theorem is applicable? Telegon's theorem. Guys, superposition based on linearity, compensation again reciprocity, but this is the theorem which is applicable for what? All type of network. All type summation of the power is equal to what? 0. I is equal to 1 to n means power absorbed is equal to what? Power delivered. Energy can neither be created nor be destroyed. So this is the Telegon's theorem. Then, okay, tell me, this is a very important one. Sir, BEL test series is available for mechanical engineering. Okay. You are asking, Mukul. You can first of all install what, Mukul? BYJU'S exam prep, and I will ask my team to give the answer for this question. Already number of mock tests are available there, right? You can join and then first of all attend what free classes, then you can continue with the paid mock test. Okay, Mukul. So just simply install what BYJU'S exam prep. Now tell me, if for a single element 2-port network in figure, what is the value of the Z11? What is the value of Z11? Kumar, you are giving the answer 10. Then what are the, okay. This is a very simple diagram. Just compare it with what? T network. When we are comparing with the T network, this is ZB, this is ZA, this is what? ZC. So what is the Z11? Z11 is nothing but ZA plus ZB only for T network. Here the ZA is what? 0. ZA is 0 and ZB is 10 ohm. So ZA plus ZB. So what is the answer? 10 ohm. You have given the very right answer, 10 ohm. 10 ohm. Okay, then what is the, okay, tell me guys, this is the 10 ohm is the answer for this question. What is the Y11 for this network? Y11 for this network. Quickly, give me the answer. 10 ohm is the answer for this question, but what is the Y11 for this question? Y11. Same question. Same question, what is the value of the Y11? All are the options given, or there may be other options that you can give the direct answer. No need to give the answer from this portion. What is the Y11 for this diagram? Okay. So some students can, is it a 0.1? Because the reciprocal of that is what? 0.1, or what? Any other answer? Right. Remember, for this particular diagram, Y parameters are undefined. They all are what? Infinity. Directly, they all are infinity. Why? Because what are the Z parameters? Z parameters is ZA plus ZB 10, ZB 10, ZB 10, and ZB plus ZC. ZC is also 0, that is what? 10. These are the Z parameters. All are equal. Then when I am finding the Y parameter, that is nothing but reciprocal of the Z parameter, right? Inverse of the Z parameter, you will get all infinity. All infinity. And that's why it is not possible to find the Y parameter for this particular diagram. Okay. So if you have any doubt, then again I am going to take what 1 minute short for that. So quickly I will give the idea about the two diagrams. Okay, then next question. For a two-port network, the condition of the reciprocity in terms of H parameter is. What is the condition for the reciprocity? We have the condition for reciprocity for what? Z parameter, for Y parameter, for H parameter, for ABCD parameter. Now that is the question for H parameter only. What is the condition for reciprocity? A, B, C or what? D, reciprocity, reciprocal network, guys. It is talking about the reciprocal network. Reciprocal means here it is V1 is applied and we are getting the I1 current here. Suppose you are changing the input, that this is the V2 is applied here and here you are getting the I2. If this particular network is reciprocal, then I1 by V1, output upon input, ratio will remain same. Ratio will remain same. Output upon input, ratio will remain same in both the cases. Then it will satisfy the reciprocity theorem. So what is the answer for this question? Yes. In case of Z parameter, Z12 is equal to Z21. In case of Y parameter, Y12 is equal to Y21. And in case of H parameter, H12 is equal to what? Minus H21. That is the C is the answer. Right? C is the answer. बिल्कुल करेक्ट है, बिल्कुल सही. सी इज द आंसर फॉर दिस क्वेश्चन. रेसिप्रोसिटी थ्योरम. 10. So guys, one student asked about the mock test. For more detail about the mock test, first of all, install what? BYJU'S exam prep from Google Play Store. Then participate in what? Mock test. You will get the leaderboard. Leaderboard means what? How many students participated in the test, what is your rank, what is your marks, score, each and everything you will get there, so that it will boost your confidence. Properly mock test with 4 options. Just after the mock test you will get the result, right? Very systematically. In जैसे यहाँ what we are doing, actually some students are giving the answer, some students are not giving the answer. But if you are writing on your copy that out of 50 questions 40 correct, 10 wrong, how many students are doing this exercise? Again, if you are doing the same exercise, but again you are not getting the idea about the other students. So try to give the systematic mock test here, but first of all install the BYJU'S exam prep from Google Play Store. एक बार देकर देखो, फ्री ऑफ कॉस्ट है. देखिए पेपर दीजिए, आप एक आइडिया तो लीजिए कि कैसे टेस्ट होता है, राइट? ऑन माय एडवाइस. द नेक्स्ट वन, the capacitor of the figure. Now it is the 49th and 50th question. The capacitor of the figure shown below has a 25 volt on it with the polarity shown at the time the switch is closed. The polarity is, this is the plus minus polarity, 25 volt on it with polarity shown at the time the switch is closed. The expression for VC is, direct expression for VC it is asked. Straightforward question on transient. When the switch is closed, means it is the switch is closed means exactly at t equal to 0 we are going to close the switch. Okay, then sorry, the capacitor of the figure shown below has a 25 volt on it with the polarity shown at the time the switch is closed. The expression for VC is, as you know, VC is equal to V final minus V final minus V initial into e raised to power minus t by tau. So when the switch is closed exactly at t equal to infinite, the capacitor will act as open circuit. So what is the final voltage? 40 volt. And what is the initial voltage is given? 25 volt. And what is the time constant? RC. RC is the time constant for this question. So you can find the RC, 200 into 1000 microfarad. 200 into 1000 into 10 raised to power minus 6. Then it will become 10 raised to 0.2 second. 0.2 second. So what is this? VC is equal to V final. What is the V final? 40 minus E initial, e raised to power t by 0.2. So this will become 40 minus 15 e raised to power minus 5t. 40 minus 15 e raised to power minus 5t. How many students have given the answer for this question? Kumar, you have given the C option. No, that is the first one. Because here you are writing the 25. No, that is wrong. 40 minus 15, because exactly at t equal to 0, when this term will become what? 1. So 40 minus 15 you will get the 25. exactly at t equal to infinite, that term will become 0. You will get the answer 40. So automatically, directly you can verify. In BEL exam, directly you can verify, guys. Exactly at t equal to 0, this term will become 40 minus 15. That is 25. Exactly at t equal to infinite, this term will become 0. So what is the answer? 40. You can verify it directly. No need to solve this question. And that is what problem with the time constant, problem with the values also. Problem with the values also. Okay, then answer is what? A for this particular question. So you are doing the silly mistakes. Yeah, that's why we are taking the mock test. Please participate in the mock test quickly within 2 hours. 50 questions with complete explanation. Yes or no? 50 questions. 25 taken by the Rakesh sir, 25 taken by me, and every question we have given you the detailed solution, so that you will you can avoid the silly mistakes. At the same time, you can solve what more question on same topics. Okay. Now finally, one questions on what steady state analysis of the sinusoidal signal. Steady state phasor sum. The parallel RLC circuit shown in the figure is in resonance. Is in what? Resonance. Parallel RLC resonance. If the 1 milliampere RMS current is given, so under resonance, what is the value? IR less than 1 milliampere, IR plus IL greater than 1 milliampere, IR plus IC less than 1 milliampere, and IL plus IC greater than 1 milliampere. Which answer is correct? Which answer is correct? Tell me. Okay. Which answer out of these 4, which answer is correct? Under resonance, the parallel combination of resistor and inductor act as open circuit or short circuit? First, that will give you the answer. Parallel resonance, under parallel resonance, parallel combination of L and C will act as open circuit or short circuit. Yes, you can say current magnifier circuit. Then IR less than 1 milliampere, IR plus IL greater than 1 milliampere, and so on. So exactly at resonance, inductor and capacitor, combination of inductor and capacitor will act as what? Open circuit. When the combination of inductor and capacitor act as open circuit, so what will be the current through the resistor? 1 milliampere. Same current will pass through the resistor. 1 milliampere, exactly 1 milliampere, and that's why this answer is wrong. This answer is wrong. Then IR plus IL, IR plus IC, IL plus IC is equal to 1 milliampere. Okay. Then watch this. Phasor sum. Phasor sum means, that is the last question. This is the parallel RLC circuit. Always remember, under resonance, current and voltage are in phase. This current and voltage are in phase. In a parallel, we are having the same voltage. Very, very basic question it is. This is IL, this is IC, this is what IR, and the parallel combination will act as open circuit. So if this is the voltage, guys, this is the voltage here, then the IR will be in the same line. Voltage and current are in the same phase. What about the current through the inductor? Current through the inductor will lag the voltage by 90 degree. This is the current through the inductor. And what is the current through the capacitor? Will lead the current by 90 degree. Lead the voltage by 90 degree. But under resonance, the magnitude of IC and IL are same. Under resonance, my IC and IL are same. Then watch this. IL and IC are same. So what is the, but they are in opposite direction. That's why, what is the IC plus IL? 0. IC plus IL is 0, because if you are writing IC as JIC, magnitude is same, then you will write the JIC. One is plus J, one is minus J, it will become 0. summation of this is 0. That's why this answer is wrong. Now IR plus IC or IR plus IL, watch this. If you want to find the IR plus IC phasor sum, this is the phasor sum, and that's why what is the magnitude of IR plus IL? Always greater than 1. IR plus IL is also greater than 1 and IL plus IC is also greater than 1. This is the result. This is the resultant. That is greater than what? IC plus IR. Magnitude is always greater than 1, guys. Right? Because IR is greater than 1. And that's why that is also greater than 1. Then this answer is correct. This answer is wrong. Answer for this question is B, for Bombay. Right? So that is what very, very basic question on what resonance, guys. Everyone please prepare this. And right, the value of L and C is not given. Otherwise, you can find the quality factor, magnification factor, that is called the quality factor. For series resonance, the quality factor is omega naught L by R. And for parallel resonance, the quality factor L should be replaced by what? C, and R should be replaced by 1 by R. So it will become omega naught RC. This is the quality factor for parallel resonance. And what is the quality factor for parallel resonance? R by omega naught L. Opposite. So this is the quality factor for series resonance. These two are for parallel resonance. Parallel resonance. So quality factor into 1. That is the current through the inductor. Quality factor into 1. That is the current through the capacitor. That is called current magnifying. Yes, you have given the right answer. Q1. Q is the quality factor. JQ minus JQ. Okay then. Hope you have enjoyed the session, guys. If you want more session, then join our Telegram channel. That is my Telegram channel or Rakesh sir Telegram channel. That is Electronics by Sanjay Rathi. And one important information for you. GATE 2024 crash course is running for GATE electronics and electrical aspirants. Complete syllabus coverage through live classes, recorded lecture, study material, practice quizzes, mock test. You can enroll now. For more detail, you can call at this number. I think number is visible to you. Otherwise, you can install the BYJU'S exam prep. Then Vision Gate 2025-2026. यार ज़्यादा delay मत करो. अगर if you are thinking about the 2025 or 2026, start your preparation now. Right? This is a very long journey with the live classes, again recorded lecture, study material, practice quizzes, mock test. For more detail, again you can call at this number. Complete syllabus coverage in both the language, English and what? Hindi. And that is my Telegram channel, Electronics by Sanjay Rathi, where I will upload the PDF of this session. Okay, तो अभी थोड़ी देर में ही upload कर देंगे just after the session. Okay then guys, thank you very much for your cooperation. Sunday है, enjoy कीजिए, मैच भी है आज तो, है ना? मैच जरूर देखिए, लेकिन साथ में ना अपनी पढ़ाई करते रहिए. Right? Thank you. Like the session, share the link of this session and subscribe our channel.